Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And hopefully we'll have about 10 or 15 minutes to go through as many audience questions as we can. We also have 4 polling questions during today's webinar, so please, hopefully we'll get you guys involved in answering those polling questions. And then finally, at the end of today's webinar, we are doing a drawing for 2 $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 2 lucky winners today. Okay, with that, we'll go ahead and kick off today's webinar, which is the reality of managing microservices in your CD pipeline. Our speakers today are no strangers to the DevOps.com webinars. Tracy Ragan, who is CEO of DeployHub, and Brendan O'Leary, who is Developer Evangelist at GitLab. Welcome to you both. Thank you so much for joining me today.
Thank you for having us.
Awesome,
yes,
awesome. Well,
thank
Tracy,
you. Looking forward to it.
Yeah. Brendan, I apologize. I said you were Developer Evangelist, but you're DevOps Evangelist. So sorry about that.
No problem.
Okay, great. Well, Tracy, I think you are going to be kicking off the conversation, so I'm going to turn things over to you, put myself on mute, and let you get right to it.
Thank you, Charlene, for that intro. Appreciate it. So today we're really talking about microservices and how they're disrupting our lives when it comes to the continuous delivery pipeline. I would say a couple of years back, when I started playing with containers, I really didn't know if this was going to be something that took off or not. And it seems to be taking over. Not only is it taking off, but it's taking over. According to Martin Henley in an article out of SD Times, in a survey they did, they claim that 86% of development professionals internationally expect microservices to become their default platform within the next 5 years. So it's one of those things, it's not a question of if, it's a question of when. So I think most of you are probably looking into microservices. Some of you may have already started down that journey, and you may start recognizing some of the problems we're going to cover here. And as Charlene indicated, please post questions. We want this to be as conversational as possible. So if there's a question you have during the presentation, pop it up when we are watching it, and we'll answer it if we feel like it's something we need to address at any point in this presentation. So the basic problem here is the way we put together software is now broken with microservices. We have literally like a tsunami in terms of disruption in how we write and deliver microservices when we shift from a monolithic to a microservice. I love this quote from Alexandra Noonan with Segment. She talked about this in an article when they first started working with microservices, and it kind of explains the complexity. She said, what happened is we would release an update to a library, and then one service would use the new service, and now all of a sudden all these other services were using older versions, and we had to keep track of which service was using what version of a library. Extremely complicated sentence, but completely accurate in its construction and accurate in what it's describing. And Randy Hefner at Forrester, he claims that with microservice development will literally fall apart without a coherent discipline managed approach to it. So some of the takeaways that you should learn from this webinar is takeaways to think about. First of all, we have to think about the build. And when I talk about build, I talk about compiling and linking, not just a CI process. Really getting down to the configuration of a binary. We have to think about how deploy and test is changed when we have these independently deployed microservices. We have to talk about the importance of the continuous delivery orchestration process because we have now a scaling problem. And lastly, we really should be thinking about configuration management. It's one of the areas that that Alexandria really points out in terms of the problem set that they addressed. But just to make it clear what we're talking about, I always like to level set. We think about what a microservice is. I'm sure most of you know by now, but just to level set, everybody knows what a container is. It's a small package of code that runs independent of the operating system because it's all built inside of it. It's very handy for doing deployments or installs. For example, at DeployHub, you can use our SaaS model, but if you want it on-prem, you can download one of our containers from a place like Red Hat. And then you have sitting on top of that, or under that, I should say, tools like Kubernetes, solutions like Kubernetes. Now, they are container orchestration tools. They help with the management of how many containers are going to be replicated to do the auto scaling, and it addresses all of that underlying ops side of this puzzle. Now, some people always ask me, well, shouldn't I just containerize my application? And there's many reasons for it. Persistent data connections, why move to a microservice platform is basically they're asking. The inability to auto scale a small section of your code as opposed to scaling up the entire monolithic. These are some of the reasons why you would go to a move from a containerized application to a microservice architecture. And when you move to a microservice architecture, you still have containers. You just have smaller functions in that container, and they pretty much have one way in and one way out through an API call. The most important thing to realize about this new architecture is this concept of an independently deployed object. That we're talking about something that's fine-grained and loosely coupled running in production and can be moved across the continuous delivery pipeline without its brothers and sisters. It's going to go all alone. So you need to think small snippets of code, and this is from Chris Richardson. He is of Cloud Foundry fame. If you really want to learn about microservices, go to microservices.io. I shamelessly plug him. He doesn't even know me, but I love his website. He's got a ton of good information in that website. It's freely available, and you can spend hours reading and learning about microservices. But he says a service should implement a small set of strongly related functions, that services that change together should be packaged together. So we still have a packaging issue to resolve with microservices. The service can be changed without affecting clients. Now, this is one that's really hard to achieve. Not everybody's going to be able to write microservice in this kind of purist view. You're probably going to have backward compatibility issues on some of these. And each team that owns one or more service must be autonomous. So if that's the case, we have also a collaboration issue. We need to be able to understand how to communicate the services that are out there. So we're going to start here with a first polling question to make this again as interactive as possible. And we just want to know where you are in your microservice implementation journey.
All right, so we're going to go ahead and launch it right now. It should be showing up on your screen. So the question is, where are you in your microservice implementation journey? The options are, we started to think how to decompose our monolithic. We are managing less than 10 services. We are managing more than 10 services, or another team in our organization has started writing them. Go ahead and make your selection. And while you're doing that, I do want to remind the audience that we are taking questions. So at any time during the webinar today. So you don't have to wait until the question and answer period to submit any questions that you have. And looks like we have almost about half of the folks who are voting. So we'll give it just a few more seconds. Excuse me. This is the first of 4 polls that we are going to have during the webinar. So hopefully we'll get everybody involved, or as many people as possible. Okay, we are about a minute into this poll, so I'm going to go ahead and close it down, Tracy, and show you the results. And looks like the majority of folks are managing more than 10 services.
That is quite fascinating. And we have 32% are starting to think about decomposing. So that makes us at, close to 70% here that are really pushing a microservice platform. And that is consistent, I believe, with what the, some of the other stats in the surveys that we've been seeing. So again, it is a question of when, it's not if. We are on that road, no doubt.
Okay, you should have the slides again. There you go.
Brendan, all yours.
Great. Yeah, thanks, Tracy. And so because of that question of when, I think it's critical to think about, what are the most critical business requirements for adapting this kind of new way of delivering code, both building and delivering code, right? And so I think if we think about the business requirements, those are the same that they've always been for our businesses, right? We want to make sure that we're very efficient operationally. We want to have a consistent view over that entire coding process, but also the deployment and security processes behind deploying that code. We know that competitiveness today depends on our ability to deliver better products faster. We want to be able to move quickly, have teams work in parallel, not in serial, and be able to outship the competition in order to ensure that we're delivering value as quickly as possible to our customers, because in every industry, that is critical for digital transformation. And then at the same time, while moving faster, we have to be thinking about security and compliance risk, because there's one method of moving fast and breaking things, but there's also been a number of studies shown that if you move fast with security integrated into how you're deploying your software, that you can actually both reduce your security and compliance risk and increase your shipping velocity at the same time. And Tracy, if we go to the next slide, there's another part of the delivery landscape today that I think is really critical when thinking about microservices, right? Today, this is what most folks' delivery landscape and tool chain looks like. And that, may have worked fine for us when we were deploying one application. It may make sense to have, lots of different disparate tools, but the silos of data, fragile integrations that these create make it really hard to scale, and hard to scale in a microservices world, because instead of having one of these, could have thousands of these kinds of connections for each different service. And so I think it's really critical to think about the DevOps platform that you're implementing, because that is going to impact how quickly, how you're able to achieve those business requirements that we spoke of last. And if we go to the next slide, that talks about this, right? If we're shifting our architecture from kind of one CI/CD pipeline to the various CI/CD pipelines that we're going to have in a microservices world, that really disrupts how we look at CI/CD. And deploying independently is really important, right? Tracy told us about how that's a critical part to making the microservices architecture really work for you, because to get that benefit of independent coding and deployment of microservices, you'll have to have each of those have basically their own CI/CD pipeline. And so the change in that architecture doesn't just impact the way you code your software, it also impacts everything about how you deploy and secure that software. And on the next slide, I think we talk about that means that builds are going to be different, right? You're going to have much smaller builds, maybe not even any build at all, right? And so that kind of traditional reliance on build time for understanding how we're doing linking or what the versions are, a lot of that is going to move to runtime. And especially if we're focusing our builds on creating a container, that gives us one point to manage. But if we've got 100 containers, now it's not just one build artifact, it's hundreds. And that really means you have less control over how you're going to be doing this deploy, right? If you were doing that kind of compile and link step in your deployment, then you had a team, maybe traditionally an operations team, that kind of controlled how things were getting into production in a centralized way. And that configuration management was then also done in that same centralized way. And having that kind of as, a central tool that a human can gronk makes a lot of sense if you're deploying, just a few or maybe even just one monolithic application. But in the modern workflow, that loosely coupled information that's really happening at runtime through an API or some other method means that you've got this configuration information kind of sprawl. And I think, Tracy, that's where you've seen a lot of customers struggle in kind of understanding what is the total configuration of the application. It's now harder to gronk
Yeah, and
as a
in fact,
human.
the application sort of is gone, right? There is no such thing as an application in microservices. It's really a collection of microservices that are talking to each other. So the fact, even the loss of the concept of an application can impact everything downstream, or I guess before stream in the new world, like tracking what version of the application you're using, your users are using. If somebody opens a ticket, what version of the application was it? They're not going to tell you what version of the microservice they're using.
Yeah, that's a great point. It's like that ability to understand, very quickly what version, what code is running is not as simple as it used to be.
So poll question number 2. We'd like to know, if you are writing microservices, what is your favorite language? What language might be you're using? Is it compiled? Is it Python? Is it Netcore? I think is an interesting one that I've been hearing a lot about.
Yeah, so go ahead and make your selections. The polling question should be on your screen. If it's not, please give us a shout out. Yeah, you have a choice of Python, Golang, Node.js, or .NET Core. So go ahead and make your selection. Again, just a quick reminder that we are doing a drawing at the end of today's webinar for 2 $50 Amazon gift cards. So please stick around, and we'll do that drawing right before we close out today's webinar. And excuse me, also we are taking questions from the audience at any time. So please, you don't have to wait for a question and answer period. We've already gotten some in and would love to have more. Okay, it's been a minute, so I'm going to go ahead and close out the poll and share the results. Python, everybody loves the Python.
And Node.js. And the thing about those are we're talking about interpreted. These are not languages that are going to go through this massive compile and link process. None of these are, but Golang is compiled. So to Brendan's point, our builds are going to become less important, I guess you would say. It's not where most of the initial busy, heavy decision-making work is going to be done.
Yeah, exactly. It's not a control point anymore, right? It's the code's running in production. Yeah.
It's a matter of a build is now going to be the process of building a container and uploading it to a registry.
Exactly.
So I talked about the loss of the application version, and I think that is a really important part of this puzzle to understand, especially as you start defining new ways of managing your continuous delivery process. Notice I'm not saying continuous integration. I'm really talking about continuous delivery, the orchestration of microservices moving through the pipeline. Now, because these smaller functions, these services are independently deployable, I've even had people, when I speak to them, when they refer to an application, they're referring to their single microservice. They've got an application that does manages logs for security. That's their application. And they push that application out and other teams consume it. So even though I'm using the term application, we use the term project in our in DeployHub. I think that with GitLab, do you call it a project?
Yes, we say project.
Yeah. So, but in general, when we think about an application, we think if you're a bank, you have the teller application, you have a mortgage application, you have a fraud application. These kinds of concepts are going to go away. And what you'll have instead is in this example we have something called the Hipster Store, which is a great microservice example that is out on Google that you can play on. You have a security repo, you have a front-end repo, you have a product catalog, you have a payment service. There was a bunch of other services like ad service, suggestion service. I didn't include it because it was just too many lines. I didn't want to go through it. But if you think about how that is pushed through the process, each time it's going to have to go, it's probably going to go through a dev, test, prod process on its own. Independent, security could move independent of the front end, independent of the product, independent of the payment. Now in monolithic, we compiled this as an entire binary and pushed it all out together. That is the biggest difference in how your life will be disrupted in a microservices world. And as you look at how you're defining your continuous delivery pipeline, you really need to be aware of these simple facts about the build going away, and even to some extent the whole process of checking in and checking out code. It changes. We're not going to see a lot of branching and merging because you're not going to have a piece of code that's 3,000 lines long, which means that these microservices will be able to move even faster because they're smaller and they're more agile. In fact, I would say microservices is what agile development has always wanted to be. Now, this is where a lot of companies will begin struggling, is when they start having multiple workflows. So for a single application today, in most CD processes, you may have a workflow for every, at most, version of an application release. But now you're going to have every component have its own workflow. That can create congestion and challenges, especially when it comes to defining a workflow for every single microservices. So I always talk about the concept of a templated workflow, or the ability to reuse workflows so that you don't have to do so much work. Brendan, can you tell us how GitLab can help solve that?
Sure. Yeah, I think that's a really critical point, because you're going to have these multiple workflows, right? Because you have necessarily, as you mentioned, the multiple deploy paths, right? And you're going to need, to some extent, those workflows to be independent, and to some extent those workflows to be linked, right? So for instance, we saw that folks use different languages, in order to write their microservices. So you may hear in this example, I'm not cool enough to be super familiar with the Hipster Store, but let's say the front end is in Node.js, but the security repo and the product catalog are written in Go or in .NET Core. Right? So you're going to necessarily have differences in the workflow, because those languages are going to require different things to get them packaged up into a container. But as an enterprise, I also have this set of requirements that are, these are the things that need to happen before I deploy it into production. And so the way GitLab looks at that is our pipelines, which are by project. So each of these projects would have the ability to have their own pipeline, but they can also then be templated and include a template, right? So the way that would happen is, I might, in my product catalog repo, have the stuff that builds my .NET Core or my Java or whatever language my backend is written in, my backend service is written in, does that compile. But then when it goes to the CD workflow, we're going to use that templated workflow to make sure that all the security checks that we our security team required get run, goes through the proper workflow process, and probably gets deployed, in a very similar way. Let's say we're going into Kubernetes. Well, we're going to, do a Helm deploy or a Helm apply there, and add it in. And then the front end repo that's in JavaScript or Node.js, maybe, it's going to have a separate beginning, right, to get it compiled and put into a container, but then share that same templated workflow in the end to make sure that we're, meeting the organization's goals around, having a consistent CD deploy process. So it's like you have these multiple workflows, but you also want to have workflow consistency, if that makes sense. And the way you do that is kind of through including templates that maybe your DevOps or your security team controls those templates, and then the other development teams that are working in their own language are consumers of them.
Thank you for bringing up the fact that these could be in different languages. I even though I think about this all the time, I forget that fact.
Right.
And the security repo could be in most cases, probably will be written by a completely different team. And you as the hipster store will be a consumer of the security repo. You might
Exactly.
even be a consumer of the product catalog. You don't necessarily, or the payment service, you probably be a consumer of the security repo and the payment service and have your own front end and your own product catalog. So this is where we start talking about how everything then, the collaboration becomes important, and how what we talk about in terms of domain structure becomes important. So poll number 3, are you currently or are you planning to manage each microservice in an independent workflow? Have you thought about that?
Sorry, a little slow on the uptake there, but it's out there now. Are you currently or planning to manage each microservice in an independent workflow? Stupid simple yes or no question and answer. So go ahead and submit your answers. And while we're waiting for everybody to chime in, one other final note that we are taking questions from the audience at any time. So just use that questions tab and submit as many questions as you want to. And hopefully we'll have about 15 minutes or so near the end of today's presentation and go through the audience questions. Okay, I'm gonna go ahead and close this one out in 3, 2, 1 and share the results. Looks like the majority of folks are yes. The answer is yes.
Yeah, that
Tracy.
is what is consistent with any time I ask this question. And if I do a presentation someplace at DevOps World, I was at Developer Week at the very end of February in Oakland, and I asked this question. Actually, I asked it the other way. I asked how many of you are managing all your microservices in a single workflow, just to see how many people would raise their hand. And I think maybe 3 or 4 people in the audience, and one of them shouted out, "We're thinking about breaking them apart." So for those of you who are not doing that, you might find out that is, you may want to consider a look at breaking them apart, because it looks like that is an overwhelming decision that many of you have made. So Brendan talked about, we talked about in that last slide, this concept of independently deployable objects and them having to have their own workflows. We now have pretty much defined what I like to call the reality of managing your Death Star. If you look at what Amazon and Netflix have created, we are really talking about building out a collection of microservices that can be reused by any teams in your organization to create applications. This is object-oriented programming on steroids, is what we're building. And these Death Stars, if we could draw constellations around them, we would see the applications. But what these are basically views of are the microservices and their API connections, who's consuming them and how they're sharing. I've started hearing terms like haunted graveyards, which is a cluster or a set of nodes and pods that are growing and nobody knows why, and they call them Frankenstein clusters, or they call them these graveyards. You don't want to deprecate it, because if you do, somebody might haunt you. And these are just basic configuration management problems that have been created because we don't have a build anymore. We're not answering these questions at compile time. We're answering these questions oftentimes at the runtime, when the APIs start talking to each other, and then we start looking at using a logging solution to track the transactions. While that's important, it's still a little late, because you lose, without that mapping function to understand what an application is and have service to service and application to service dependencies, you lose that traditional software bill of material report. You lose the ability to understand impact a single change will require, and you lose the concept of your application to start with. So how are you tracking service to service and application service dependencies? It's our last question, and I think it's the most interesting. Most people I talk to, yes, we have things that are, say, in our heads, and that's a very valid way to do it, because that's how we did it in the build or in a script.
So we have three separate answers here for you for are you tracking service to service or application to service dependencies? I love this one, yes, in our heads. That's a great answer. So yes, in our Helm or deployment file, yes, in our heads, or yes, in a spreadsheet. So go ahead and make your selection, and we'll give this a few more seconds, and then we'll go ahead and close this one out. Take a look at the responses here. Okay, I'm going to go ahead and close it out now. And here are the results. Well, at least it's not in their heads.
Well, between the two, and remember this question we asked was you could answer, you could use more than one. So you could be tracking that in a spreadsheet, and you could be tracking it in your Helm file. And the reason why that may be happening, or you're tracking in your head, is because when you put things in the Helm file, you still don't have the real vision of what an application looks like. You might, based on a label, be able to see that, but you don't know the version. And you don't know the version of the microservices. And when we track things in a deployment file, which is what we have to do to send it out to Kubernetes. I mean, that's the way Kubernetes determines how to run these and how to configure the cluster. It uses those files. But at the same time, because they're static and we can't make those relationships, we lose some of that configuration information. And it's hard to see that it's hard to make some impact analysis or make some real data-driven decisions about what should be pushed out when you have to go and review the Helm files. So we're taking it this is a summary of everything we've talked about in terms of what that new microservice pipeline is going to look like. Your build is going to be really creating a container image. You're going to need to track, and this is how some folks are doing it in their head or in a deployment file, the service to service and application to service dependencies and configurations. You push a single microservice out to the cluster as it's needed. You collect feedback, and then you do configuration reporting and identify your impact at that point. That's what your new CD pipeline. Now you're going to have other things in there like security scanning and more testing, but the areas that we focused on today looks like this. The big change here, builds are not doing the configuration management. Now you're putting in your deployment file, you're going to have multiple workflows, so your continuous delivery pipeline is now scaling beyond, maybe you might have a few dozen workflows to literally hundreds. So just a word from your sponsors here and what GitLab and DeployHub have been working on. We understand that what we need is a little bit of normalcy in our life, and that probably is more true today than it would be in other times. And how DeployHub fits into the workflow process. So what GitLab can do is manage those multiple workflows and track everything that's happening in your CD pipeline. What DeployHub does is it fits into the CD pipeline to do that, to aggregate back to what an application version is, and it tracks all of the independent information about each microservice. So what we're doing is we're sitting outside of the CD process, looking into what's being updated based on a new build, or a new container image is created. We know then there's a new version of a microservice, and then we automatically increment the version of the application, and then we call something like Helm to push it out. So we're tracking and doing the mapping before you do the deployment. And what that does is it builds a relational database that allows us to report to you how how the applications are consuming microservices. And if you're a microservice developer, you have the information about what applications are consuming your service. So the results of this overall solution is you're going to see that your container image build is going to replace your monolithic compile and link process. The GitLab delivery pipeline is going to support these independently deployable services with hundreds of workflows. DeployHub can fit into that CD pipeline to do the critical part of your configuration management and to provide this, what I like to call continuous mapping of the service and application relationships, or your new bill of material report. And then GitLab and DeployHub together, we centralize reports and we provide that much needed visibility into containers and what's running in your cluster. So it provides that value stream. It tracks everything based on a microservice, not just based on an application, but it can aggregate it back to the application as well. So DeployHub is a SaaS-based product, and it creates a platform for sharing, managing, and releasing your microservices. Think about it as an internal marketplace for microservices, or any reusable component for that matter. DeployHub tracks and shows the complete picture of your application at any point in time, and you can see the differences between different versions of your application based on the different versions of the microservices that it's using. You can also support database updates. We don't talk about it in this particular presentation because we're focused on microservices, but it can support database updates along with your application packaging. And so in the end, what we're doing is we're doing everything we can to simplify the complexities of microservices. So organizations can really achieve the level of business agility that they've been pushing for, starting from our very first discussions around doing small changes and being agile. And just so everybody knows, we did open source the mapping. There is a project called Ortelius.io. Abraham Ortelius was the first map maker. He created the first world atlas, and we felt it was an appropriate name for an open source project. So just to kind of summarize how DeployHub fits into the process, DeployHub organizes it creates a central catalog of microservices. So it creates an organizational structure for your microservices, and it does that based on a domain-driven design. So the more you learn about microservices, the more you're going to hear domain-driven design. It'll be hammered in pretty hard because the more you can define microservices based on these problem spaces, the better you'll achieve reuse. Then we do mapping and deploying of those microservices. Now I say deploying, but we call things like Ansible and Helm to actually do the heavy lifting. We do the push at the point in time we do the mapping. We can support both your traditional models and your microservice models. So if you've got a hybrid monolithic microservice environment, we can support that. We really do push that domain structure. So initially what you do when you start with microservices, you start containerizing your application. So they're still in a monolithic look and feel, basically. Then what you want to do is you want to start breaking down you decompose your application, and you want to really start thinking about domains. And DeployHub helps you with that by allowing you to define domains and publish microservices into those domains. We then do the versioning by allowing you to create your application package, which is a logical view based on the microservices that you're consuming. And then once you do that, we integrate into tools like GitLab to automatically do the versioning as you push it across, so that you can independently release the microservices, but still track what your application version is consuming. These are some of the numbers we're getting from customers, that the automated relationship mapping saves about 1 to 2 hours of manual work per week for every dev team. The sharing reduces redundant coding by up to 50%. The maps and the visibility for release engineers are critical because it really gives them that the data that they need to make decisions quickly about if they should push a microservice across or not. And we fit into the GitLab pipelines so that you're supporting microservices without any kind of costly redesign. So with GitLab's templating and our mapping, you are 99% there. I would say that the 1% is making sure you've got some solid domain structures to solve the problems. Brendan?
Yeah, and so I think where GitLab fits in is, the rest of the tooling that gets you to that deployable point today, as we saw earlier, can be a very disparate, unintegrated set of tools. And so GitLab is a single user interface, a single application that provides an entire DevOps platform and a complete DevOps platform. And so we're seeing this convergence in the industry where those traditional vendors that only provided maybe one of the pieces of the DevOps lifecycle, be it source code management or CI/CD or container registries, each of those are consolidating and bringing additional tools into their platform to provide one continuous DevOps platform. Well, that's been GitLab's mission for some time. We've kind of been on that road ever since we brought GitLab CI into our source code management tool. And so we're pretty far ahead, and we have also the concept of that DevOps platform as a single application. So whenever we bring something new into GitLab, for instance, we purchased a company that does dependency scanning. Their name was Gymnasium. Instead of keeping Gymnasium running, we integrated their code directly into GitLab so that it's just tightly integrated as a single application. And that gives you a lot of emergent benefits. It makes it single user experience, a single data model, a single place for managing all of your permissions. And so we really believe that that is the new way that the entire industry is going. And we've kind of been on that path for some time. So that's what GitLab allows you to do. And when you have that single tool, it allows you to kind of build in all of the DevOps practices you want to your everyday developer workflow. And so the fact that it's all in a single tool means you're able to give feedback to the developer directly as they're coding, whether it's issues of a new dependency that may have that the developer's trying to bring in that may have known vulnerabilities, or a new security hole that they accidentally introduce as a part of this change. That continuous feedback loop really lets you have your developers move at the speed of development and deploy your code with confidence, because all of the CI/CD, security, and other checks are going on continuously within a single application. And we then streamline that DevOps journey, much like we saw with DeployHub earlier, where you can adopt part of this single application and then slowly expand your team through the pieces that make sense. So while we are a single application for the entire DevOps lifecycle, we also provide integration points where you can get started with either just source code management or just our CI tool. So you can move your source code from where it is today into GitLab, but keep the rest of your DevOps pipeline, whether it's CI, CD, security, etc. Or you can keep your code where it is today and start just with GitLab CI. Once you've entered those points, you then can slowly self-graduate to the rest of the GitLab application. So once you're doing CI, well, then it's pretty easy to say, well, why don't we take a look at the security that's integrated directly with CI? Or once your source code is in the repository, it might be easy to say, well, let's do a proof of concept to see if GitLab CI might work better for us than our current solution. And so while it is a single application, it's also critical that you can adopt the pieces of that application at the speed that makes sense. And in many enterprises, we see that adoption curve different for different teams. And so that's something that's enabled really well through the fact that GitLab as an open source application at its core has fantastic integrations with the rest of the world as well. But as you take advantage of more, you can reduce your integration costs and get more of those emergent benefits of a single application. Great. Thank you so much, Tracy, for having me, and thank you everyone for the great questions. I'm hoping to get to those and answer them coming up here.
Yeah, so we've gotten a lot of questions in so far from the audience, but there's plenty of time, guys. If you have a question, go ahead and use your GoToWebinar control panel and submit your question. And let's go ahead and dive right on in, try to get to as many as we can. Let's see, first question, in theory, shouldn't there be just one microservice for each functionality So when a microservice is updated, all applications that use that microservice will automatically be using the latest microservice?
That is correct. That is how you can define in your deployment file how you want to set that up. So that's your choice. And in theory, yes, you want to, if a new microservice is out there, you want the application to automatically consume that new microservice. But the point here is you want to know about it. So if you're consuming a external microservice, the microservice development team in security, and a new one gets pushed out, you don't necessarily need to do anything, but you may want to know that it was done. And that is the point of tracking the application versions automatically through the pipeline. So if a new microservice gets pushed out, you want your application that's consuming it to be automatically incremented so that you know you have a new application out there. Because in essence, when a new microservice gets pushed out and your application automatically starts consuming it, you built a new application without even knowing it. In our old way, we would have compiled it and we would have labeled it with a new application and we would have pushed it through the pipeline. So yes,
All
that
right.
is correct, and that's part of the problem.
All right. All right. Great. Next question here. We are thinking to move to microservices architecture, but we worry about the scaling and hardware limitations. Can you shed some light on this?
I'm not sure how to answer the one on the hardware limitations. That's why many companies are going into Amazon or Google because you don't have to worry about the hardware at that point. And that is the whole reason why you do microservices and Kubernetes, is so you have auto scaling and fault tolerance, something that we've been working towards for my entire career. And this is the first time that it can be a real reality, that you have that kind of auto scaling. Now, if you're going to build your own cloud, I'm not an operations person. I can't answer that. Brenda, maybe you have some insight on what that really looks like. But I think most companies are going to, an Azure or an AWS or a Google type of platform.
Yeah, I would agree. I think that microservices, if implemented correctly, can actually leverage hardware better because, as you mentioned in your presentation, Tracy, now if we need to scale part of the code, right, if there's a long database call that takes up a lot of resources, we can isolate that into its own service and scale it differently than the rest of the application that may not need, more hardware thrown against it. Now, doing that requires, some sort of orchestration tool. So I think if that is a concern, then microservices alone, I mean, as an application architecture makes sense for you, but you're also going to need an orchestrator, right, that handles it. And as Tracy points out aptly, the easiest way to get going with that is a managed Kubernetes cluster from, one of the hyperclouds. But even if you're in your own hardware, there are solutions for that as well that may not be spin your own Kubernetes cluster. Of course, that's an option, but that would be Kubernetes the hard way. But it's also possible to, have tools like OpenShift or Rancher Labs to help manage and orchestrate those, the various hardware that you're going to be throwing against the cluster on premise as well.
All right. All right, great. Next question here. The greater difficulty when a change happens to a microservice, there's no automated way of knowing the impacted services. Are there any tools for that?
That's what DeployHub does.
And there we have it.
That is exactly the purpose of DeployHub. And in
Right.
fact, we track down on the think about, we hear this single source of truth, we hear configurations code. DeployHub embraces those concepts. When you think about a microservice, you have to think about everything about that microservice. The container, the repository it came from, the SHA number, the environment variable settings that's built into it. We track all of that gory detail. And that's what we version. So anytime any of that is changed, we track that. And anytime an application is consuming it, we track that.
Okay, great. So the next question here then is, what about to change a unique development language, let's say Python? Is that a good practice?
You mean to, I'm not sure the question, to change the language itself?
Right, I think so, yeah.
I've never heard of anybody doing that, like going in and making your own version of Python.
I'm not quite sure exactly if if
You
it's
put it,
changing from one code
whoever
to
asked that
another.
question, if you could put that again in your chat, exactly. It's an interesting concept. I'd be curious to hear more.
Right, yeah, okay. All right, well, we'll go ahead and move along then. Let's see, here's one. Is there any shift happening toward network delivery as pipeline, as that's an area not exploited like ADM and infra areas? Any views?
Brendan, on the pipeline side?
Yeah, sure. Yeah, I mean, I would say that there are a number of folks who are looking at, the network is obviously a big aspect here when you're talking about, a number of microservices that are interconnecting. Managing the network of what's allowed to talk to what in between them can be really tough. And so one way to do that is, of course, Kubernetes has a lot of that built into Helm. And so I would say if you're using Kubernetes, then looking at Helm would be the best way to do that, because controlling all of the network through within your Kubernetes cluster is done really easily through Helm. When it comes to outside the cluster, again, I would say all the hyperscalers have support for, HashiCorp tools like Terraform. And I would say that's probably the best practice that I've seen today, is like, let's define the network as code as well, so that as part of our deployment process, we're going to be, deploying and ensuring the state of the network is the same, as well as, of course, the application and the infrastructure and the microservices. So I would say that yes, there is a shift happening towards, seeing network as a part of the holistic infrastructure and doing that as code as well.
Okay,
And
go ahead.
just as a comment, whoever asked that question might take a look at, start learning about service mesh as well.
All right, great. So quick time check, we're about 8 minutes to the top of the hour. I think we have time for maybe 2 or 3 more questions here. Next question, how would you manage security and compliance in a microservices architecture? And what metrics would you track?
So think about everything you do today in a monolithic, you're just going to do more of it, because you're gonna be thinking about container scanning. And there are some good solutions on the market for doing that kind of scanning. The one thing that an area that I've recently kind of realized could potentially be some problems, and I think Brendan can talk more about metrics, but I just bring this up, is that now that we have a connection with a container and the version of Kubernetes that's running, security needs to be able to track the vulnerabilities at the Kubernetes level as well as at the version of the container level. So that's something I think that operations they're starting to realize and starting to look at how to solve that particular problem.
Yeah, I agree, Tracy, completely. So container scanning is part of the GitLab security pipeline. We wrap CoreOS's open source container scanner there. And I think that's really critical, right? Because you're building this container, and for those of us that have built containers, that the first line is from and what container you're starting from. And maybe sometimes that's from a blank container, but often we're saying from Ubuntu 18.4 or some other container that we're leveraging first. And so then you're going to have a whole bunch of layers, some of which you created in the container build process, and some of which are really like dependencies, just like any other dependency your software, the code actually has. So it's critical to scan each of those layers and understand, as vulnerabilities are released, that it can impact those layers. And then yes, Kubernetes versioning, I think, is another thing that you need to be super aware of, because that can impact the security of what's inside the cluster, obviously. So I would agree with both of those points.
Okay, and I think we have time for one more question here, and this actually may be related to the previous question. How would you capture the relationship between different microservices, and how would you track compliance against those relationships?
So I'm not sure how what you were talking about in terms of compliance, because that can have that's a kind of a loaded word. But in the DeployHub world, a microservice that's not consumed is not it should never be deployed, right? If it's not consumed, it's not being used. There's no reason for it to be in the cluster. So that should be the first level of compliance. Don't deploy microservices that nobody's consuming. And again, in the DeployHub world, how we see things is still based on we pull everything back to an application, and every time if a application consumes a microservice, it pushes it out, or it determines if it's already out there and it doesn't need to go because it's already been deployed, it's already running in a cluster, and it's the correct version. So some of the things that we need to start thinking about when we talk about audit and compliance are things like the same things that we always did. Who made the change? Why was it made? How did it get pushed to across the CD pipeline? Now, in our old world, in our monolithic world, we kind of created this big package, and we would collect many changes, and we would track, you know, from a ticket, we could track all the way to a production release. That stays the same. We don't change that. The difference is that now you're tracking it based on a single microservice, and that microservice is going across at the same time as other microservices are going across. So an application could have multiple updates and you don't even know it, even though you're the application team. So in order to start tracking that, we have to still go back and aggregate back that application, even though it's a logical view, and track the change request and the changes that are going through the pipeline for that logical view of an application. Because then we can start defining rules and things like compliance. So, for example, in my world of compliance in the monolithic, I would say that you have to be able to compile your application and verify that you're using certain versions of production libraries. In a monolithic world, you may want to be able to say, we need to have a clear view of the impact of this microservice moving across the pipeline. Who are you impacting, and can you notify them before you move it out so they know if their application breaks, it's because you just updated a microservice they're consuming. So you're going to have different rules and different levels of compliance. I always like to talk about a compliance scorecard. Your scorecard in a microservice world is going to look a little different because you're just going to have more of it. But the same levels of compliance should apply to a microservice that it did to an application. But now we have to aggregate it back to the application so we can track what's occurring to the teller application for the bank, not just for the user contact information microservice that just went out that impacted four of the bank's applications.
All right, great. So we are about 2 minutes to the top of the hour. So unfortunately, that's all the time that we have for the question and answer period. I do want to thank everybody who did submit questions. If we didn't get to your questions, I apologize, but please know that the folks at DeployHub will be getting a copy of all of the questions that come through, and I'm sure Tracy and her team will be more than happy to follow up with you post-event to get your answer. And then also I want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, that's fine. You'll have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, in the last minute, let's go ahead and do the drawing for the two $50 Amazon gift cards. Our first winner today is Curtis H. Congratulations, Curtis. Our second winner today is Everett M. Congratulations, Everett. We'll be following up with both of you offline to get your gift cards over to you via email, so check your email for that. Tracy and Brendan, thank you both for great presentation today. Really appreciate it. Lots of great information.
Thank you. And thank you, Brendan.
Yeah, thanks, Tracy. This is great. Appreciate it.
All right.
Everybody stay safe.
Oh, yeah, absolutely. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody. And as Brendan said, stay safe.